Okay, so there's two ways we could take this question. The first way is we could be looking at the concentration of CO2, and the second one we're looking at the concentration of the oxygen 18 isotope. For this explanation, I'm going to focus on the oxygen 18, and so with that we have our graph down here that has our oxygen 18 isotope concentration, and that's going to be increasing as we go this direction. And then on our x-axis we have our atmospheric temperature, and that's going to be increasing as we go this direction. Now, with oxygen, we get a lot of oxygen in the atmosphere. We have a lot of evaporation of water that happens. Now, we have evaporation of water happening more often when we have more energy, so happening often at higher temperatures, which often means we're having that happen like in the tropics and places like that where the air temperature is warmer. So we have water evaporating out of the ocean. Then that air mass gets carried to other places around the planet. In this example, we're talking about moving out to polar regions. So it gets colder. Once you have cold air with liquid in it, right? We have some of that precipitate out. You could be forming clouds, you could be forming rain, you could be forming snow, hail, etc. And when that happens, those molecules then can fall back to the Earth. So when we look at our oxygen 18 isotope, there's sort of two main isotopes of oxygen that we look at with evaporation. We have oxygen 18 and we have oxygen 16. Now, of those two, the heavier one is oxygen 18. There's actually more in that nucleus. It is a heavier molecule. So it's also going to take more energy to get that up, to evaporate that molecule out of the ocean up into the atmosphere. Once it gets into the atmosphere, it moves over that polar region, it cools down. It's also going to fall out of the atmosphere faster. You're going to have more of that falling out of the atmosphere because you have more in there to begin with, and it's going to come out pretty quickly. So when we look at the concentration of that oxygen 18 in the ice cores, what we find in modern day when we look at what we know. So we see the snowfall, we can measure the atmosphere. The current modern day relationship between those two things ends up pretty linear. I'm just drawing a generic linear relationship here. So as we have more oxygen 18 isotope, we're also observing in the modern day a warmer atmospheric temperature. So that allows us to conclude that this was probably true as well in the past. And so if we had a high concentration of oxygen 18 isotope in the past preserved in these ice cores, that probably means that we had a higher mean annual temperature as well. So I hope that helps, and have a nice day.